Hey guys, Professor Calculus is here, and today in this video we're gonna solve the integral from negative infinity to infinity of 1 minus cosine x over x squared dx. And the result that I saw was derived with contour integration, but personally I love Feynman's technique, so I'm gonna use Feynman's technique here. But before that, make sure to like and subscribe, as it is free and you can always change your mind later. So I'm gonna define, as always, I of t to be a parameter from the integral of negative infinity to infinity of 1 minus cosine of tx over x squared. And if I find I of 1, I have found the integral from negative infinity to infinity of 1 minus cosine x over x squared dx. So first, I'm going to take the derivative of I of t with respect to t. Thus, I'm going to have I prime of t, the derivative with respect to t from negative infinity to infinity of 1 minus cosine of tx over x squared dx. And as usual, this derivative is going to move inside and it's going to make a partial derivative. The partial derivative, partial t of 1 minus cosine of tx x squared dx. I prime of t is therefore, so this term and this term is constant, only this term is variable. So I'm gonna have, if I take the derivative of this according to the chain rule, negative cosine derivative is negative sine of that function times the derivative of tx with respect to t, which is x over x squared dx. Thus, I prime of t is the integral from negative infinity to infinity of x sine tx over x squared dx. I prime of t is these two cancel out, from negative infinity to infinity of sine of tx over x dx. Now I'm going to do a variable substitution. I'm going to say u equals tx, du is t dx, and dx is dut to the negative 1. Doing this replacement, this substitution gives me the integral of sine of u over x is, obviously x is ut to the negative 1 times dut to the negative 1. I'm going to cancel out 2. And I prime of t is going to be the integral from negative infinity to infinity of sine of u over u du. Now this integral is known as Dirichet's integral. So this integral from negative infinity to infinity of sine u over u, I solved it also with Feynman's trick of integration. It is equal to pi, exactly. So therefore, you can go and see it in my channel. It is available in my channel. So I prime of t is pi. And if I integrate I prime of t and pi dt, I'm going to get I of t to be equal to pi t plus c, some constant of integration. And to find this constant, I'm going to equate it from 0 to 1 of 1 minus cosine of tx minus over x dx is equal to pi t plus c. And if I let t be equal to 0, cosine of 0 is 1, 1 minus 1 is 0, definite integral of 0 is 0. Thus this term is 0, and pi times 0 is 0, thus c equals 0. So the integral from negative infinity to infinity of 1 minus cosine of tx over x dx, x squared, sorry, is pi t. And if I plug in t equals 1, I'm going to get the integral from negative infinity to infinity, which is equal to pi. So that is the final answer of my integral here. That was not real hard, The only hard part was this integral, which I solved, and you can go and see my other videos. But anyways, make sure to like and subscribe, and I'll see you next video.